Hello and welcome to another day of streaming with Ginger Bill on the Odin compiler. Yes, another one of those days. I've gone down for the resolution today because people complaining about it being 4K, so hopefully it should be 1080p. I hope. So let's link the link for the Twitch thing to where it needs to go. So I'm going to go clearly look around this way, actually this direction, at the thing that needs to be done. So where is it? That there. That there. Right, there we go. There we go. So hopefully I'm now back. So yes, I'm in like a different, you can see my fashion sense for today. That's what it is. Yeah, the whatever kind of thing. Yeah, just trying to show whatever. There you go. There's my fashion. So I'm gonna wait till people get on because it's clearly just very early and random time as well. I guess many people aren't even finishing work yet, but this is my work time, so me working. So what are we working on today? It's the same thing we've been working on every day, trying to take over the world. No, not really. It's we're working on integrating the Tilde backend, which is part of the quick C compiler, which is developed by Negate. And in this, we're using the Tilde. So Tilde here is the Tilde backend system, or the tiny backend system. It's just a name. We call it TB, tuberculosis for short, obviously. And this is an SSA-based compiler based off some of the work of like Cliff Click's papers and such like that. And we're effectively, I'm just going to help alongside it for Odin as well as this the quick C compiler that Negate's doing, so that we can have an alternative to LLVM for Odin, because we've been dependent on LLVM for about nearly 7 years now, and I wish I wasn't. That's the best thing. So I want to try and get away from it as much as I can. We were not getting rid of LLVM. We're going to still have that as a backend. We just want an alternative backend as well, one that's a lot faster, because anyone who's ever used Odin knows that the front end is pretty fast, but the back end is pretty slow, because LLVM usually takes about 90% of the entire compile time. Yeah, 90, which is not always the best thing in the world. So it's kind of the... Yeah, it's just the bane of our existence. And also we hit loads of LLVM bugs because each LLVM has a new release. They break things, of course, and then they have to patch it very quickly through our request saying, hey, could you fix this because you've broken things? Or now we've gotten to a point where they've changed things so much, we're just saying, yeah, we're not going past LLVM 13 officially or 14 unofficially, like 15 and 16. Yeah, no, they've changed everything, and it's also breaking things, so no. So other than the speed, the bugginess, you can't fix LLVM either, so we're going to have to do something ourselves. Again, just to get the stuff out of the way so people who have not watched the other videos or the other streams can understand what's happening. Yes, we have looked at the alternatives. The alternatives are libfirm. Libfirm is, we found out, 15 years old. It's old. It should have been fixed years ago, but they don't even support Windows at all. It still assumes a POSIX-like system, so even trying to compile it in Windows, it doesn't really work. And also doesn't really officially support AMD 64 yet, only x86 32-bit, and Spark are the official ones, as it says, which is kind of like, Spark? Really? That's always fun. So that's one thing. QBE is another one. Problem with QBE is you can't use it as a library. It's meant to be used using the text format, which means I can't really multi-thread it very well. It's going to be very slow. Then you've got this stupid parsing stage it has to go through. So great, speed's benefits are out of the way, and also its code base is bizarre. Yeah, it's small, but it's bizarre, to say the least. What else is there? There's multiple ones. GCC was never an option because of licensing issues. Compiling to C was what was a valid option. We'd have to do a very small subset of C. We couldn't do like direct translations, like transliterate it. We'd have to do a very specific thing. Effectively, still be an SSA. So SSA, for people who don't know in the know, is static single assignment which is an intermediate representation you can use for optimizations with. It's effectively a graph-based system where each kind of like instruction is a node, which goes and you only assigns to an arbitrary register, like infinite of these, and then you have this build up this graph system where you do the optimizations on a graph. Graph is a mathematical term, like nodes and edges and all that lot. Yeah, not graph isn't like bar charts and such. Well, good English and the confusing terms that we use in English, obviously. But yeah. Thank you for the chat. Good. So I'm just looking at the chat. Anytime I am having this face, it is I am looking at the chat. When it's this face, I'm looking at the camera, and when it's this face, I'm looking at the screen. So this is kind of the very different things that are going on at the moment. But yes, so that's kind of what is happening. So we're going to start going on. I've been doing a bit before earlier, but I was working with Negate on certain things, fix things as we go along. So let's get going, shall we? And tonight's drink is, not even tonight, it's this evening, is cheap lemonade. Diet lemonade, in fact. This is probably not, it's very cheap. When I say cheap, I mean like 26 pence per 2-litre bottle. Yeah. So, shall we get started with some programming? So we go back onto the scene here. And now, we're showing off here. So I've got binary expressions working. So we look at this debug code here for main. This is working so far, as expected, as it should. Procedure calls still don't work properly because calling convention stuff is going to be fun. We're still working with Negate to get this to be not necessarily magical, but there's a lot of missing features to make it better than LLVM already. Like one of the things we've already done at the moment is getting give it the debug type and it produces the prototype from the debug type, which is what we want. Because before it didn't do that and it was annoying. So yeah, fun that was. So questions are curious. Do you know what kind of effort it would take to design a backend from scratch? It depends on what type of backend you want. If you want a simple lowering to like whatever C or x86 or whatever it is, pretty simple, surprisingly. It's not that much work, but it would be non-optimizing. So, but that's the problem. If you want an optimizing backend, you have to design it in a very particular way and actually have to do a lot of planning. It's not just something that you can do as you go along. So the strategy we're doing again is the SSA stuff. Let me just get SSA. I don't think necessarily. Actually, this is probably not a bad thing for resources on SSA. I think I had it saved earlier. So SSA bibliography here. This is just so that people can learn more about SSA and stuff. No, there's no Cliff Click stuff in here, but the Cliff Click paper I had. Where is that paper? I'm trying to find it. This one I'm thinking of. There we go. Here's Cliff Click's paper. Simple graph-based intermediate representation. Using a CFG stuff here, so it's still SSA kind of based, but it's a lot better because, let's put it this way, he knows what he's doing. And yeah, you think, oh, he's still using inheritance here, so it's not that great. But it's like, no, I know it's not that great. But, this is where the big book comes in. Nice. He clearly knows about arenas and memory allocation strategies. And it's like, yeah, he's worrying about cache line, also trying to make stuff that's fast to allocate. And it doesn't have much stupid cache misses and everything like this, keeping it small. He's like, yeah, he knows how to do this. So it's very much yeah, he's got a vtable there, but the vtable is probably very, very rarely used anyway. And clearly, if it's just like used for a name or something like that, that is not a problem. It really isn't. Okay, you're wasting a pointer for something that's very rarely getting called. And again, for how TB's been generated, it doesn't even work this way. I think they just store the name directly on there. There's no need. It's just like, okay, we're wasting 2 pointers now, or a pointer, or whatever. It doesn't matter. It's absolutely fine. Link to the papers. Yeah, I can link to the paper in the chat. This one is... Hopefully that works in that chat. And here's the SSA bibliography. Sorry, this is in Twitch. You probably won't be able to see it on the YouTube recording. But I will probably try and link it into the description if I remember. So hopefully this helps. Have you thought about taking Morix's full LLVM build and using it as an SSA test corpus? I'm not sure what that is. Sorry. Let me just double check. Oh, I know what you're saying. No, complete. No, it's unrelated. unrelated to what we need. No, I'm not talking about, so no, we don't need to. Okay, hello, welcome to the chat, Philip. Right, so hopefully this is also a good time for streaming for people. I didn't want to do it too early because I don't know when people can watch things because time zones and everything, but I thought this would be an okay time zone for most people. At least you got Americans in the morning, Europeans during like the afternoon, and then anyone else in the evenings. It should be okay, except for maybe Australians. So sorry, Australians. If you're still watching, why are you still up? But yeah, I'll paste. Yeah, that's a good place. I'll post them in the link for the Discord. So this is a nice bibliography, and then this is the click paper. Yeah, I know what you were talking about, the thing when you... Yeah, this one's irrelevant. It's not LLVM. We don't want LLVM, so we don't need to use this for Odin. It's kind of a different thing entirely. It's irrelevant for us, if that makes sense. Okay, good. There we go. So what I'm working on now is some of the expression stuff. Like, for instance, I've got assignments working, and last night I figured out how to work on multiple, like tuples, or not tuples, but multi-term values. So this is someone asked a question earlier, like Tilde. So Tilde, as we were saying, explain at the beginning of the show, is the backend system we're going to be using new for Odin. So we're implementing a second backend. LLVM is going to be still there. Keep that clear. LLVM is still going to remain, but we're going to be having Tilde in there as well. So it's going to be fine. Okay. As well, and Tilde is going to be a hell of a lot faster. And not just that, it is so much faster. Just because it's not dumb, and LLVM is just so badly designed. It's so many. Oh God, it's awful. Wonderful. There we go. So if you want those links, they're also on the Odin Discord in the Randomer channel. So Randomer, obviously, it's quite random. But yeah, always check out the Odin Discord as well. So if you've never done that, just go to odinlang.org, click on the community, and then go to hang us out on the Odin Discord, and it should take you straightly to the Odin Discord for you. Absolutely wonderful. You can always check out stuff out like that. It's fine. Okay, so let's get on with development, and I'm just slowly porting things across. So we've got a lot of the binary stuff. We're ignoring any of the array arithmetic at the moment. Anything can become like array arithmetic, like, you know what I mean, like array programming in general, matrices, arrays, what it's SIMD, whatever. That all just gets stubbed out at the moment. It's big to-dos. But that's fine. So the one thing I wanted to do at the moment was like emit comp. And you could always do comp against nil as well. Yeah. We should try and do that. Sorry. Is comp against nil. Okey-dokes. So, there's a byte swap. Yeah, that's fine. Let's just copy and paste the LLVM code, because most of it will translate because it is SSA based, but certain things will not translate at all. You have to be very careful about what you're doing, and you have to kind of know what you're doing as well. CG, like if I just did that, changing the LB to LLVM back into CG, which is code generation, if people wanted to know, is null is a thing here. So these are just comparing against 0 is what I want to do. Where's Tilde here? So I usually work, again, most people know, I go really tiny fonts, and I usually have 3 or 4 panels on this because now I'm on a 4K display. It's so much better. Like I'm having to have 3 panels. It's like, oh my God, why didn't I do this before? So much productivity boosts. What I'll do is a comp. So this is the comp equals. And then these both have is nil on there. These are like wrappers in LLVM, but we don't need that in. Yeah, so we're going to just do TB node. Yeah, we don't even have struct EV yet, do we? It's a good question. Do we have struct EV yet? No. How we're going to implement that? Because technically you can't do it in TV yet. But I'm thinking this through, okay? Yes, the number one programmer trick is knowing what you're doing. It's a big, wonderful trick that people seem to forget about, that maybe you just need to know what you're doing. Indeed, indubitably. Right, so carry on with this. Is this null? So we can... The res value thing here is funny because this is just predefined, but we don't need to do that because we just do CG value. Do that one. X dot value. God, there's the LLVM crap in there. Oh, lovely. You can get rid of that crap as well when we're done. So we can just do this slowly by step by step. We can do a comp. So this is going to be... oops. X dot kind equals value. We don't want an L value, we want an R value. And then we want against nil, don't we? Comp equals, and then we just need to make this a 0 here exactly, so it's the nil value. So effectively that will work fine. DT we can do as well. Data type DT equals data type of that. This won't probably work for everything, so it's not a problem. So 0. And then we just need to make sure this is a Boolean of some sort. I'm guessing that's what it needs to be. I think. I'm going to find out in the source code when we generate it all. Not equals, that's fine, we can get rid of that as well. Right, so there we go. We've got two different things. TB stands for tuberculosis. That is incorrect. Yes, it does stand for tuberculosis consumption. This one still needs to be done. No, GB to do doesn't exist. GB panic does. To do bill. We have something like this element extraction. So development pointer element value. This one just needs to be compared against 0. Wait, what? Oh, comp against nil, and that's just a comp. Yeah, that would work. Right, that's that. That's fine. This one's going to be easy because it's the exact same thing as this, in fact. Because they are very simple to do. Slice is a little bit funnier because we know we need to do the same thing here. So we need to mock this one out. We could probably just do this. Right, I'll just do that. GB assert panic. Yeah, we'll just do this. Keep just doing panicking on everything. Same with that. Same with this again. I'm not doing it yet. I need to figure out how, well, the best way of doing it is my best opinion on this, if you know what I mean. The struct things are the same again. Yeah, it needs to be a module one. It just needs to be an integer, and that'd be fine. In fact, we'd just say it's a const int, I think. Does that even work? Yeah, whatever, it'll be fine. So this is just a basic comparison. We haven't got the comp against that yet. Emit actual comp. This is a little bit more involved because you've got a hell of a lot more complications going on. Like sometimes you have to call runtime functions. Yeah, sometimes you have to call all the other things on top. It gets fun. If you didn't guess. So let's do this, shall we? Yeah. Let's just do these anyway. Just copy and paste most of this thing because it will probably work for the most part. Oh, this one's going to be fun because you have to compare the... Like that. It's questions. Hello. Well, okay. Hey, Ginger Bill, you seem to have broken links on TTV about page in your channel. I do I? Yeah, they don't have any spaces in it. You're right. How the hell do I... no. Clearly tells you how much I use Twitch and also understand things on Twitch because I don't know how to change that. I'm going to find out quick. Not the channel settings. Description. Where the... Those links are fine. Yeah, how do I change that? Okay, so it's for some reason it's got... I never actually got rid of these spaces. It's just they... For some reason it doesn't work. Let's save those changes. That should have been updated now. So it has now. Great. Other questions I've just not seen yet. Is TB state implicit? How does it know what object you're submitting instructions for? Do you have to call begin and end translation unit? And state is global. Is it multi-threaded? Okay, so there's loads of questions here. Okay. Let's break down these questions. Is TB state implicit? No. You have to pass it around. So there is a module and then there's a function in TB. So this module is the big translation unit, and luckily for TB, we only need one of these because we only want one translation unit. We don't need multiple. And that may sound like, oh, why wouldn't you want multiple? Shouldn't that you get some benefits? Like, no, it won't actually help the compiler linker in this case either. What it actually will get is because TB is already multi-threaded safe. It's been designed to be multi-threadable, in fact, and incremental with its build optimizations as well. So that should be good fun. And yeah, so I'm just typing stuff. I can't type today. Right, where's the... It's there. Right, question. So yeah, so Tilde's already very multi-threadable in that case, so that's great. You do have to call it begin end translation. Yes, that's fine. The state is no state global state. It is all that's why it's all multi-threadable, so it's great. Yeah, I've already changed the settings. You just have to refresh your page. You asked because you keep seeing a module pointer. You're not seeing in any of the TB parameters. That's not because they see a function pointer. So each of these parameters have a TB function, and the function data does actually store which module it's part of. Yeah? If that makes any sense. So that's fine. So but the thing is, when you generate a function, it is still multi-threaded safe, like how it's all been worked. So there's nothing hidden with the wrappers in that sense. The wrappers for me are just so I can add a type system on top of it all, because there isn't really any type system in this. So for a good example of this, explain what this means is that you have some basic data types. Yeah. You have integers, floats, pointers, tuples, which aren't even a real thing. They're only access via projections, and control flow. So a control region in this particular case is a basic block. If you've heard stuff like, it's just a block. It's called a control region because that's the technical term if you ever read an SSA paper. That's what it is. So this is where those things come in. So that means there's no structs. Structs are only a debug thing. So how do you deal with structs is the question. Well, it depends on how they're in the memory. If it's in register, it's probably stored in floats or ints or multiple registers or whatever. Or it could just be a pointer into the stack, and then we access that by adding a local. Because when you do a local, instruction local, all we'll ask for is the size and the alignment. That's it. It's just some memory. You can always zero it by doing mem0 on it, or memcell, whatever you want to call it. So there is a mem0 in here now, thanks to my... It's wrong, but... Oh no, it's right now. It's right now. That's fine. So it's all in that case very simple, and it actually makes things a hell of a lot easier as well, because it has no concept of a struct really, which is beautiful. Compared to LLVM, you had to get around with its nonsense and add all your own padding in and all the things, and actually couldn't go around its alignment. So it means I can actually now define things. I'm not going to, but I could in any way I want, and the layout just works. And you've got some beautiful things. If I wanted to have a new data type, which had like different line, I could say the offset thing. Oh my God, it's just so much better. It really is. Oh, so much better. Okay. How's it going? You missed the first 25 minutes? Because that's fine. It's absolutely wonderful. Just getting along. So yeah, it should be okay. I'm just mocking things out at the moment. So mocking things out means just mainly just... Okay, so that's that. There's a lot of stuff I'm still missing in this. And when you mock things out, you just put big like panics everywhere just to say things don't work, which should be okay. Okay, so this one doesn't need to be mocked out. We can actually implement this one because it's just a bit set. So we have some transmutes in here. We have... That's fine. This is where things get a little bit more complicated. We have an icomp and we have to be passing in the right one. So, res, does that get used again? Yes, yes, it does. So CG value. And then we have TB instruction, sorry, inst. And then this is a compare equals. And res node left hand side node. Yeah. And that's just going to be a Boolean in there, which should be nice. And then what I'm going to do with these is make sure that they're all flattened. Which is a little bit like, why would you do that? I'm like, trust me, it'll make sense. This one here is, says the right hand side value. And then when we got to do this bit here, yeah, we've got to do another comparison here with the equals. Oh, I forgot to do the... Oh, look at that funk. Someone actually got my reference last night when I was doing the funk thing. Yeah, it's from the Mighty Boosh. I'm surprised. So that was good. But yeah. So what else am I looking for? RS value node. So they're the comparisons of that, and that's a Boolean again. And then we've got another arithmetic thing going on here. Another bool. Because it might not be a bool. It might actually just be... No, it is a bool. And then we can return that there. It's all fine. Okay, then this one is a little bit more... Really? Did I really just do this? Because I didn't actually need to do this. I could just return it in both cases. So CG value. TB instruction comp equals P func left node, right node, T bool. And again, for this not equal, we just change that to not equal. Just checking, I do flatten it out here. I do flatten it here, at least. So that's always kind of a good news, I guess. In fact, I might just flatten it here as well. Just flatten it there as well. There you go, done. They don't even need the flatten, but I can do some good asserts here. So BGB assert. Perfect. And I can do those asserts here as well. Left, right, left, left, left. There we go. They're equals, I don't mean to do that. Left isn't even a thing here. Wait, where the hell is left and right defined then? Oh, they are left and right, but... How weird. Okay. Left is a const, or if left is nil. Yeah, that looks like that's an LLVM thing. I'm gonna do that for the time being. Just because it doesn't seem right otherwise. Because that's kind of coming along. It's lovely. So flattening. Okay, so the flattening is... you can actually just show you what the flattening function does here. All it's doing is checking to see if it's a symbol. And if it's actually just a symbol, it flattens it to be that thing. If it makes any sense. Yeah. Could probably also. It also has one other check here. If it's address. Yeah, if I can get the data type on it, I can also do a load here as well, I'll be honest with you. So I can always do a CG emit. No, address load. Maybe. That should be it. Yeah. What the fuck did I just type there? What? Oh, I know what's gone wrong. I'm not very smart. Does it not take? What do you mean it doesn't? DT, address, alignment. Oh, and is it volatile? Okay. Align, bolts. Type line of value, I guess. And cast it. There we go. I don't know if that's a good idea or not, but it should be. We're gonna find out. So it's like, oh, I have a value thing, but it might be a variable. In which case, I want to strip that away because no. So okay, so the flattened thing to be clearer is like, look, a symbol is a different thing to like a global symbol, like a function pointer, or like may have it like a global address. So the way that TB works is that doesn't exist. It's not a node. It's not a TB. So you need to convert that to a node within the function itself. So when you've converted it to that into the TB function node, it's fine and it exists. Otherwise, it's not the real thing. With the address thing in the case here, I'm not sure if I should be doing this with a flattening of the node, but what that's doing is saying, hey, this could be an R value or an L value. This could be an L value. The address thing is an L value rather than R value. By default, it's an R value. And then what you have here is effectively a way of abstracting away, because before we had a lot of bunch of hacks in LLVM for the LLVM backend. Some of it was poorly my fault, my decisions, but some of it's LLVMs as well. And we've kind of just been redesigning it such. So if you look at how the backend system now works, we do move it to the right here, and we look at how a value is defined. The value here, if you can see, is we have 4 different variants on the value. We have a normal value, which is kind of like an R value. This is an L value. This is the global. This is multiple values. Yeah. So we have different things here. So this is like, these are the different things that a value could be. It's separate from an address, by the way, because addresses do exist in, we make a distinction. So addressing is to extend the addressing mode. So having all of these together makes the addressing modes a bit weird, if that makes sense. Any other questions, please feel free to ask, because they are weird. Right, so that should be fine now. Okay, I'm just thinking out loud. Okay, so there's two different things that can refer to a global. You need to have a specific one if you want to refer to a global within a procedure, essentially, and flattening maps from one to the other. Correct, yes. So to understand how it works here is if we look in the TB header file, which is here, we can look at some symbols. So the symbols is effectively an external, global, or a function. Yeah? So we have an external definition, a global one, or a function. That's dead easy. But the problem is these are not nodes. These aren't things within a function. Like when you make instructions with the function, they have to be TB node. So what we have to do is get the symbol address. So you pass in the symbol, which is one of those external globals or a function, and it produces a node for us that we can deal with on the function. That's what the flattening thing does. Because hypothetically, we don't know where this CG value comes from. It could be just a global variable with a symbol in it. Because if it is, then it gets flattened. Now, this address thing here to make an L value into an R value is not necessarily a good idea. I don't know. If trivially possible. Where would you send someone to learn more about different memory strategies? Yeah, I think the other one, I'm not sure. Well, we could always do Ryan's. Ryan Flurry Arenas? We kind of agree on arenas anyway. This is kind of the thing. It's just sometimes we have different agreements in like language design with regards to arenas. But it's like, yeah, there's a chance. So this is another good one. I'm going to post this into the chat in Randomer, but also into the Twitch chat for the people there. So you can always check it. This is an all right thing. This will teach you stuff. But the idea is untangling lifetimes. And yeah, this is the thing you have to understand is when you come to do custom memory allocation and such, you only really need arenas. Like unironically, like even TB, all of it's just arenas. Like the TB stuff is just an arena. It's beautiful. But the point is an arena correlates with a lifetime. So when you do a bunch of allocations and they all share the same lifetime, you do an arena with that. So when the lifetime dies, you just free the arena. And that's kind of the trick. This is something which people are starting to rediscover. Quite funny in this case, but it's like, yeah, but that's the thing. When you do manual memory management, you shouldn't be thinking of the individual objects. You should be thinking the grouping of this lifetime, which is what the arenas allows you to do. You can do all the things with arenas, and you can keep stabilizing it. It goes the way. I'm not sure about Go arenas. Go arenas do seem interesting. It's interesting, but I don't know if they will be stabilized or not. It's one of those I don't know. It's just how garbage collected languages work and stuff. It's a bit different. Again, arenas are very useful things. We can always recommend Ryan's post here. He breaks it down. I just gave you the shorthand of it, obviously. But arenas and... it does give you the whole thing there. It's fine. Arenas do correlate to a lifetime. That's the best way to put it. And once you start getting used to this, you start going like, why did no one teach me this before? Or why did I not know this before? And it's kind of like, well, because most people who teach this sort of stuff aren't, how do I put it? They aren't that great to begin with. And they don't really know much about memory management. Or they use the old stuff. How does one handle things that resize with arrays, like dynamic arrays? So this is where things get a little bit funny. Not everything should be done with an arena. So if you look through the Odin compiler, we actually have three memory allocation strategies. There's three. The first one is permanent memory. This is an arena per thread. So you have a permanent arena, and you just allocate to that, and you never freeze it. That's what the permanent arena is for. The next one is the temporary arena. This is effectively another arena we just scratch to, and we usually clear it afterwards, just for temporary stuff when we need it. And when we clear it, we can usually have blocks as well, like I say, begin this block, end this block, begin like temporary, end temporary, and it will free everything within that with our temporary arena stuff. And then there's the last one, which is just a heap allocator. So stuff like a dynamic array or a hash map like an Odin, because we don't actually know what the length of this is, we do resort to dynamic memory. And in those cases, it's fine. Technically, in your worst case scenario, if you are allocating memory, you will be wasting twice as much space than you need. And the reason why is that say you start 1, we double it, 2, double it, 4, double it, 8, if you add these up, that is 2 to the n minus 1, isn't it? So effectively, you are always going to be 2 times, you're going to waste twice as much memory than you're actually using for your arrays, if you're scaling by a factor of 2, obviously, or with your maps and such. So if you don't mind wasting twice as much, you can just use an arena and that's fine. But usually in those strategies with the dynamic arrays, you can sometimes know the upper bound and you can just reserve it. And when you reserve it, you can just, that's fine. You don't need to resize after that. So there are different strategies with arenas and such. It is just getting a little bit difficult, but a lot of the time when you're doing arenas, you just try not to do those strategies if you can do it. Not always, sometimes it's not possible. Again, that's why Odin compiler has 3 different strategies: permanent, temporary, arenas, and then a heap allocator. Again, the heap allocator is there for the dynamic arrays that we don't know the lengths they need to be, and also the for the hash maps as well. If that's hopefully answered your question. I can always do a question on arenas. Like, this is what these chat streams are for. Like, I'm developing Tilde, but I clearly do that in free time. But I'd also, not free time, like in my normal time, I should say, not on stream. But I could also just teach things if you'd like. I do have a tablet I can write things with. So I can always do that when necessary. I have no idea what that question means. Okay. Yeah, but cautions about performance. How does... Wait. I didn't mean to pin anything. How did I unpin something? I was just trying to read something, not pin it. So you have to be cautious about performance. Do you really need to resize? So this is not about performance. Resizing in place is not about performance. It's about minimizing memory usage. So performance would say speed, and then memory usage is a different thing. So this is the problem with those 2 different strategies. If that makes any sense. Heap allocations will be slow because you're just doing all that, there's a lot of that bookkeeping that goes on. And because you've got a lot of bookkeeping, it's not necessarily the easiest thing in the world to deal with, but yeah. So if you know an upper bound of a dynamic array, an arena works because you just keep going until it's full, and then you're done with that, and then you free the whole arena. Correct, yes. Pretty much. Or anything allocation strategies. You have loads of things you're allocating at once individually, but they all share the same lifetime. Use an arena. There are different, in my allocation strategy series, I do talk about other allocators in here. I didn't even talk, I always kept saying, coming soon, here's going to be the virtual memory stuff. But that's something which I've wanted to write, but I'm not, really hard to get it right, because you have to, there's so much nitty gritty stuff to understand about virtual memory that it's not trivial, if that makes any sense. So, yeah, so it is kind of a bit weird. But yeah, arenas are nice. Once you kind of understand what an arena is and what it's for and how to use them, you'll start realizing, wait a minute, these are great. Like, why did no one tell me about them before? Like, why not? Like, it is very much these are not new ideas. These ideas have existed for 50, 60 years, but they're only starting to, in a weird way, they've been known in the game industry for probably 30 years, 20, 30 years, but they've only started really just becoming like, I don't know if they are, like, hopefully we can push them to become a bit more mainstream, because then it's like a different way of thinking about problems, especially when it comes to allocations. Because it's one of those things where, this is one of my disappointments. Okay, so this is a minor tangent. I'm on a stream. This is what I'm talking about. Tangents is what I like doing. One of my disappointments with Rust is not the ownership semantics, but the lifetime semantics. The lifetime semantics are a bit ad hoc. Yes, they're now trying to do non-lexical lifetime semantics. Obviously, they're trying, but the problem is it's not that. It's more of a, I would love to have stated like, hey, I want to, when I do, I would say a lifetime or something, I say, hey, the lifetime of this variable is at most the length of this loop. At the end of this loop, it dies. Or the beginning of the loop, it dies, whatever the thing is. Then anything that was allocated within that lifetime can be freed, like an arena. But the problem is, you can't really annotate it that way in Rust, because that's not how Rust was designed or anything like that. So it's kind of like, so the stuff that I actually want to describe with regards to lifetimes, I can't. And the stuff that I can describe is not very good, and it's just pervasive, and it's just messy, and Again, I'm not just, and also I do have issues with the ownership semantics. Like it's technically, it's an affine substructural type system, not linear. Because it's affine, because it's an imperative language, it kind of needs to be, unfortunately. Affine means that you've got this weakening aspect to it, which means, the dumbest way of thinking about it is it means it has 0 or 1 owners of value you can have, not just one owner always. So because that has 0 or 1 in it, it makes some of the mathematics annoying, makes some of it is not as powerful as it could be. Because of that weakening, the power there is gone. Are arenas stack-based? Arenas are arenas. So if you want to learn more about this, I probably do have to put to my thing at this point. Let's go to my thing, articles. Go to my allocation strategy series. Here we go. So I'll just make sure this is SSL1. There we go. And that should answer some of your questions, because we've got thinking about memory and allocation here. Linear arena allocators, stack allocators, pool allocators, free list allocators, and buddy allocators. The next on this list I wanted to do was virtual memory and such. To understand how virtual memory works, and then on that, how do you implement absorb virtual memory? But it's very much I've been wanting to do this for years. Literally, it's like nearly 2 years old since the last time I did one. But yeah. Who cares? I'm awful at writing. Who'd have guessed? Much better at speaking. But yeah, this is a very good series to read, apparently. So just read through it. That's all I'm going to say. Okay? Good. Isn't Rust supposed to be memory save and thread save? That's the best center point. Yes. It did used to have GC in it as well at one point. But that's not what I was talking about, Russ. I said the aspects I was saying about its features are disappointing. Like, I don't actually have a good control of lifetimes in the way that I would want to specify lifetimes. Lifetimes are value kind of based in Rust rather than like scope based or like an actual like control flow based. It's very bit weird to explain. Like, I've not seen a language do it this way very well. The languages that have done have actually just used arenas. So it's kind of there's no middle ground. And you can do unthread safe things in Rust, obviously, and memory safe things in Rust. It's just the defaults without going to unsafe kind of prove things. That's all I'm saying. NLLs. What the heck is an NLL? Too many initialisms here. An NLL is a what? A what? Non-lexical lifetimes. No, so I already mentioned non-lexical lifetimes in my little rant. That's the problem. What I describe isn't actually possible. Yeah. They try, but what I mean, I was just write some pseudocode. This is not Rust, it's just like pseudocode. In a game, and in many things, even like any graphical application, I kind of love to do, you always have an event loop. So you have for the window open, yeah, like this. Then what we're going to do is free all in the, I don't know, the frame arena here, yeah? And then you can deal stuff within this, right? So everything we would deal with in the frame arena, anything that has the lifetime of frame. So this would just be a frame lifetime, and everything you would mark on that would be that globally. Like, this would be a global thing you'd reference to. So then you could easily do this, but like, you cannot do this. Oh, you can't see the bloody code. Of course I'm going to do that. There you go. Back to this. This is kind of like the pseudo code to here. I was trying to like do. In fact, can I just do? I can. Isn't there a like distraction free? Shift F11? Yeah, that is it. But it's, yeah, this one here. And this is kind of the thing I'm kind of talking about. Is that you want to specify everything with this frame. Now, correct me if I'm wrong, you can't do this in Rust. This is not the same as a not, yeah, so you want rarefied lifetimes that can be operated on like values similar to scopes in Goose or whatnot. Maybe? I don't know what that is either. That's there's a load of things I'm learning. Is this Google Juice is an open source framework for the Java platform. I don't know. This doesn't sound like what I want. Yeah, exactly. It doesn't seem like a memory region. I'm just trying to say that this is the point, is if you have something at basically, you can have a memory region, obviously, and you get many of the benefits that you would normally get out of arenas, and you could probably just tell the language, hey, needs to be arena kind of thing. It's not just that, if that makes any sense. So this is where I'm saying like a lot of like language things aren't very well done. If it makes any sense. They do kind of annoy me. Yeah. Is it premature optimization to give arenas a NUMA latency parameter? Yes. Yes. Like, I'm not even sure. I'm sorry. I've been trying to figure out why we'd even want that. Like, yeah. But yeah, most people don't even have to deal with NUMA. You're right. Like, it's not a thing. So NUMA, for people who don't know in the know, is non-uniform memory access. That's what NUMA means. But yeah, that's just confusing me. So unless you're on cells, SPEs, then yes. Yeah, that's what I mean. Like, unless you're like on like the PS3, I don't really see why you need to worry about it. Yeah. You think no? So be very careful. I'm not saying you can't implement arenas in Rust. I'm just saying it's a very different thing. I'm kind of like saying I don't want to have to do the free all here. I want it just to be, it would have done it magically. Like, this is kind of the point. A lot of the time, there's not the right annotation system to do what you need with Rust, and this is why it's disappointing to me, because it's not really giving me the control that I want. Like, again, I'm not even criticizing the concepts of those lifetime and ownership semantics on their own. I could do that before quite easily. I'm just saying that they're not even like doing it well. Aren't they supposed to be thread local if a block scope lived? Nothing to do with NUMA in that case. Yeah, it was fine. Yeah, you're just thinking about it's fine. No, just going to discussion. So, right, should we get back to programming? Because I got a bit distracted reading the chat. Could do this to make it distraction free, obviously. Ooh, look at that. Look at that, man. Distraction free. But yeah. You're intrigued. The other type of... Right, let's discuss this here. What am I trying to do? We've done the most... Oh yeah, we're still doing the comp stuff. I thought I did most of it, didn't I? We got up to bit sets. bit sets. Here's this. Okay, so this is checking to see if it's endian specific crap. So we need to do the right byte swap stuff. Yeah. And then we go back to the core type stuff because you've got the swapping stuff. Now we've got to go through this rigmarole. This is going to be fun. So if it's this, we need to figure out which... That's an LLVM hack. We can ignore that for the time being. And to be honest with you, all of this can be simplified and we don't even need the stuff. That's just a TB node. Yeah, like that. And then every single one of these, we just return from it. Like this node, don't have to worry about it. In fact, we can even just do short circuiting on that one specifically as well. So this one is going to be return. No, we can just do. Yeah, res for result. So no, it's shadowing it, but who cares? CG value res, and it's like T-ball. Yeah, in fact, no, we could always just do it early as well. There's no... Yeah, that'd be fine. Or... Oh yeah, let's just do that. That's TB instruction. Compare. Equal. Func. It's not even value, they're nodes. Left, right. I think that's it, to be honest with you. That's fine. We can have a break on the end there. Not equal. Then there is... Got the greater than less thing. This is the unsigned stuff. Sign, is it great? So not equal. So it's then, these are signed or not signed. So they could actually just simplify this even further. It makes sense? And then we can just do this check here. So if, then we can just do this into one. Oh god, this gets simpler already. Don't you love it when code gets simpler? That's I greater than or equal to, less than, greater than or equal to. Is signed, yep. Oh, beautiful that is, beautiful. Make it a little bit smaller maybe. Oh no, it's because it's doing a stupid word wrap on this. Oh, for fuck's sake. I thought it was going to be fine, but no, it's doing a word wrap, and I thought, oh, fine, whatever. Right, we can do the same thing now with floats, can't we? The only difference here with the floats is that they will have the float variants of this. That makes any sense. So we just do this. That's is signed. None of these are the signed form, but they're just the float form. And also those are the left hand side and the right hand side. Yeah. Type ID is just should be in this list. SIMD vector, we just block it out for the time being. Yeah, that should be it. So this is out CG emit comp. I mean, InsoBot's not wrong. This is great about InsoBot is clearly just a chatbot, and he's just said, "Oh, InsoBot, in this stream, programmer and DJ Ginger Bill has taken us on a tour of his programming language Odin." Well, I used to be a DJ, not anymore, but like, yeah, that's yeah, nice InsoBot. Let's just chat to him. See how he's doing. How are you? No replies? No replies? Oh. Oh. Shame. Shame. Very shame. He doesn't reply back anymore. I love that lovely Markov chain. That's such a great Markov chain replies. Oh, we're missing that. We're missing it. It doesn't have the latest LM model on it. Oh, it's still, but yeah, it's still better accuracy. Yeah, this is the funny thing about InsoBot. InsoBot was great. It didn't need to have anything fancy. It didn't need to be like ChatGPT or anything like that. It was great. Oh, disappointment. The real disappointment that's going on here. Right, no, let's carry on back with programming. I'm guessing we're going to be probably only doing this another 25 minutes or so, I guess. Maybe more. I don't know. I'll figure this out. Okay, so we've got that kind of mocked out. We're just slowly mocking this all out, by the way. And actually, we could probably find out how much of I've written already. So Tokai should be on there. And I'm just now looking for anything that says Tilde. What? Oh, for God's sake. I want it just... Right, I can't remember how to do this. I don't think Tokai works this way. So it's not found. It's like, yeah, I just wanted to do a wildcard. So how do I do this with a wildcard with Windows? Because I don't remember how to do any of this. Like, people who want to know what I'm just trying to do is like, you can see what I'm trying to do, right? How do I do Windows wildcard things? Like, right, I just typed in Windows wildcard things. That's not actually a good thing to search, is it? Wildcard CMD, all files. Because technically what I want is tilde de star. That's what I want. But that's not useful. That's just, I just want a list of all of the things. And maybe /s. No, that's even worse. Well, Tokai doesn't work when I do that. Look, error. Yeah, it doesn't accept. That's what I mean. Wait, the problem is, does accept Tokai? No, I don't think it does. That's what I mean. So I'm going to figure out, can I find a way of it expanding this so then I can just pipe that into Tilde? Using big brain skull here, man. Gotta get that lovely, gotta polish that skull. Right, fine. So, what can we do to figure this out? Because this is something, even if I remembered it, I think I'd forget it again. Like, I think it's something like for that in Tilde, something like that. No? I'm just going to do an echo of like that. So that works. So that bit works. But now I just want to put them into one file. Yeah, Tokai does accept multiple files. If I do Tilde, look, like if I do this, yeah, const, not token, Tokai, it works, right? So what I'm trying to figure out to do is how do I get this kind of thing here, concatenate all these files together, like these strings. Batch for concatenate results. You know what? I'll write a batch script. It'd be flipping quicker. Right. Go to the build.bat. Build bat. Here's my batch script. Get rid of that. Get rid of that. Hide all this. Okay. We don't need to keep building it every single time now, do we? Okay. That's great news. So now I'm just going to do, so push directory. Let's go to source, pop D, %f for the file in Tilde, % star. I'm just going to do echo %f for the time being. Right, this is just incorrect syntax. Where have I done it wrong? Well, how do I do a for loop thing in like this thing here? Is it that? Wait, what? In was unexpected this time. I'm like, but that worked in the command line. The/b bare bones, great, but it doesn't work for what? Why does it work? It does work. Okay, so what I want is dir/b tilde b like this. Wonderful. But I want to turn this into one string. Like I want it on a single line. I think I know what I've done wrong. I think it might be double percenting thing crap, isn't it? So it's like something like, I think it was something like that. So it's like %f in tilde star, do this, and then I'm just going to do %f for the echo. I think it's something like this, isn't it? Right? And look, it works. So that worked. Yeah? Okay, we're getting there. We're getting there. And then set list like this maybe on a new line. Echo list. So tilde. I'm just messing around at the moment if you didn't guess. Like this. Yeah. Echo is off. I'm like, did just ask you to do it for me? No, that's not what I want. So tilde list is empty. So then I kind of want to append to it. So I think what I need to do is set. Oh, I know what I need to do. I've got it. So %F, double percent it was. I'm going to find the string of an empty string. I'm going to ignore any of the stupid stuff like that. And then going to check the error level. Yeah. If it's 1. If it is 1, then we're going to set the tilde list to be itself like that. Space %F for the file. Else, we've then got to do same thing, I guess. Let's just try it again, right? Let's try that. Oh, fuck it. It's not a normal programming language, man. It's batch. Okay, that worked. Do I just need to do this and I don't even need to check the error message? Yeah. Perfect. That's wonderful, isn't it? We got it work, guys. We got it. Okay. Right, we got it. So now we're going to do it. Woohoo! We did it. And it worked. It fucking worked. Sorry for my swearing, but like it worked. Oh. You would have absolutely gone to ChatGPT by now. No, I was trying to remember how to use batch, okay? This is how we do it here. And I've just realized I'm insane, but I did it. And look at this. So we've already written nearly 4,000 lines of code for this backend. That's not bad actually, by the way. That is, I've mocked up a lot of it already. A lot of it is mocked up. I am now a batch man. Sorry. What we need to do is we need to go full camera and go, I'm batch man. Oh yeah. Not Batman, batch. Batch. Because it's .bat. God, oh God, what have I done with my life? Look, I couldn't even remember half of this. It's like, oh yeah. This is beautiful, man. Beautiful. Don't tell anyone else to give up your dreams. This is an empty string, by the way. You didn't guess. But like, yeah. Beautiful. Now, here's the question I want to know. You can't do that in a single line in the command line, can you? Can we do this in a single line on the command line? Because if we can, amazing. Amazing. This is an achievement in itself, guys. We figured out the horrors of batch. Can we not do this in one line? Oh no. Yeah, wait I think that's fine. So what we could do is we could make our own make our own script, shall we? Because I've done this before. Let's do it, shall we? Right, where the heck do I store the Tools. Here it is. So we're going to add a new one in here. We're going to have a new, let's call it wild dot bat. Yes, I do want to change the extension. Because what we're doing here is amazing stuff. Echo off. Now I just need to remember how to get the first parameter. I think it's like %1 or something like that. Yeah, %1. Yeah. But if we have more than that, that's fine. But I think %1 will be fine. Yeah. So now we can go back to this. No, that one. Did I get rid of the command line? Yeah, I did. Go back to here, change the scope. Tokai. Wild. I'm going to do Tokai star. So that did that work? No. No, it didn't. Okay. Let's try and figure this out again. That's the Odin one. There we go. Let's figure out why Tokai, what? I thought I just had it in the thing here. There we go. This wild list doesn't work. Well, is it because the percent is in the wrong place? Is it percent I need? Or not? Echo %1. Tokai, yeah. Echo %F. Doesn't work. It never goes through the loop because this is not stringified. This is just going to be the wild card. Guess it needs to be stringified. Nope. Yeah, clock is slow as hell. That's why I'm using Tokai. Or Tokai, or however you pronounce the thing. Okay? Tokai, technically, isn't it? But whatever. Clock is so goddamn slowed. I'm calling it John. Right, John we're doing here is better. I can't say the other name properly, so I'm calling it John. Right, we're going to figure out how to do this, okay? Because we're insane. So echo wildcard. Sorry, that. We get this. We don't need the % strings on it by the looks of it. It just needs to be that. Then we have this. Echo is off. I didn't... I know echo is off. I wanted to echo it. Oh, echo on. Yeah, that's useless. The wild card is Tokai. That's perfect, and that should be a string. Yeah, may not be. It just needs to be in here, right? Because like if I do this, right? That works, right? Well, it did. It did work. Maybe it doesn't like the echoes at the end, and we just need to echo is off. This is still this does not even get found, so that's why it's not working. What did we do differently here, guys? What have I done? Huh? Wild list is not found. Huh? Huh? I know it's empty. I gather that it's empty. But like, why isn't this iterating is what I want to know. It's iterating there. Great. So it's finding it now. But then wild list. If I... Doesn't work if I do that. What about... Delayed expansions. Oh god, you're right. Oh my goodness. I completely forgot. Thank you for whoever was the genius who remembered that. So first off, I'm going to put this in my build file and call this properly. So this is Tokai Wild, and I'm going to put tilde star in there. And now it's actually working correctly. Okay. If I do that, it now works as I expect. I don't need to do this. Then it works. But now if I do that, it doesn't give me the right answer. So what the heck is different in here to there? Anyone got an idea? How many compilers did I write before writing Odin? Many. Probably over a dozen. Why? Yeah. I am wasting time doing this, but it's fun. I'm learning Batch. I should probably change the stream to Bill struggles with the words language. He's probably the first language he ever learnt as well, which is so bad. Yeah. Just it is esoteric, you're right. Well, I've just wasted a lot of time on that. Let's get back to reality. Back to reality. Right, there we go. We're back to Tilde. Look, PowerShell is bollocks as well. It is more coherent, but I don't want to use PowerShell ever because I hate PowerShell. So, reasons. This is why when I make scripts, I usually write it in Python or even Odin nowadays. I don't even bother trying to do batch, but I do use batch here because for most things it's simple enough. But in general, that's just insanity. And yeah. Yeah, I know. You could probably use it, but the thing is like, look, I use batch because it's on every single platform. It does. How long does it take to build Tilde with symbols? A second? Do you want to see it? Dump. You want to see it again? That's Tilde with I could even do a clean build of Tilde. That was doing a git pull, clean it, and then push the .lib and header file across. Yeah. There you go. But maybe I'm just being like cheating. Because I've got a build script here. And it's changing. So I'm just going to do... Can I do a clean build? Just to prove it. Is it like /clean? Okay, so it's clean that. I'm going to rebuild now. So it took half a second to build everything that I needed with debug symbols. So beats the 45 minutes out of LLVM, or 20 minutes on this machine. And you wonder why I hate LLVM. Oh, not half bad, not half bad at all. Waiting half a second compared to 20, 40, 50, 2 hours, whatever, for LLVM. And then it might break as well. Okie dokes. So. Oh. Yeah, CMake. People thought CMake was a good idea. Those people have now added 100 problems. I can't even say the word because it's that bad. CMake, wonderful. Right. What shall we do with a drunken sailor early in the morning? There's a lot more expression stuff to go along, by the way, but I'm not that like worried about it. Because if I go to build expression internal, is what I want. There's a few things I'm missing, obviously, but let's just look through build expression here in internal. So there's ternary ifs. Oh wait, we could always do if statements today. That actually is a thing we could do. Like here's a ternary if statement, which is a little bit more fun. But shall we do it? Z, so if x is greater than 0, x is greater than 0, no, next I'm doing the old fashioned C style. What am I doing? Let's do x, let's do Odin style. So it's 3 if, no, 3 plus, what's it, y plus 3 if x is greater than 0, else y minus x. Yeah? Now it's going to hit the ternary if, and now we're going to learn some more advanced features of LLVM. Right, these are advanced, not LLVM, advanced features of Tilde. TB node, incoming values. We then have the regions, so these are the incoming regions. Let's call them regions, that, or control regions. And let's create them, shall we? So TB node, region. I'll look for control in here. No, is it in statement? I've only ever used it. Yeah, it's just region, and then we can set a name to it as we need. Then equals just doing this. Done. Else. And then we can set some regions. So this is the then, if done, if else. So that's done. Oops. Done. Add a space there. Else. Okay. So now we need to build a condition. So we haven't even got that done yet. So build condition. Then else thing. CG start block. No, we need to set. No, it's TB set control. So it's instance set control or something like that. I don't remember. It's setting the control region. It's that. Okay. And then we need to set the control region for the stuff that we need for the then block. Yeah. The incoming values, because at the end you're just making like a phi node thing. So that's what's happening. Questions I've not seen. Okay, so how much would Odin's progress benefit from a boost in popularity? Good question. I don't know. But the one thing, I know this is, don't take this silly. What Odin would benefit from is literally donations, like being able to fund people. Like, again, funding the gate to work on Tilde is a really good thing would be. Or funding people to work on the core library and such, or working on like documentation. Like, it's not just for me. Like, that would actually help people. Like, because time is money and it's taken a lot, it would benefit these people a lot if you think about it. You're giving people some a job. You're helping them like it's not just popularity per se, like how many people are using it, but it's also just being better in general. And if people want to help, that's great. But then someone's still going to have to manage them as well, and that's like a time thing, and it gets annoying, is what I'm trying to say. Emit conversion of the CG build expression. Won't do this CG value. I'll do that. Yeah. And then I've got the same thing here. I don't need to do that bitcast. So then we just need a TB instruction go to in this particular case. Done. Then we just set a new control block for the else block. So do that there. This is then Y. Set a jump to done. And then finally set the control block to be done. Now we're building a phi node. Now I don't think I've actually touched phi nodes yet in TB. There's a lovely one here which sets up the phi node for the bleeming most common case. So which is the done region, and then we have incoming values 0 and 1. But in this case they could be anything. So this is where things get a little bit fun, because it could be an L value or an R value, and you have to be very careful about that. So what I may do is this. So we're going to do res kind. So these values are technically need to be flattened, but they'll be flattened when they go to the conversion stuff anyway. So that's okay. So then from this, we just want to make sure GB assert incoming values. This kind is CG value, or it's going to be an address, because it could be an address. That's not a problem. Same. Another thing we could do is make sure that they are the same as well. Sorry, assert, it keeps autocorrecting to the wrong thing. Because I keep doing it wrong, it keeps learning. So the result of this is going to be the same as well. Like that, yeah? Then when we come to do the node is that phi node. So it's got phi 2, which is again, it's a common operation enough that there's usually 2 of them. So then what we need to do is return that res. So this is a bit of a hack, but it should be correct. Like, we haven't got build the condition yet, so that's fine. Build. Oh. Where the heck is build condition then? It's in general. Okay. So we've mocked out most of that code, interestingly, but no, we're not done yet with the build condition. So it's in general, but I'm going to put it in expression. And I'll put it around about here-ish, I think. It's not a bad idea to do it. Just how much? It's not much code, so it's just copy and paste it. Like that. There's no blocks, but this is a TB node anyway. Which is fine. Most of this should work. This is the fun bit about it. Most of it should. So this is if it's a constant. Is constant. This is a weird edge case. I don't even know what this code is doing, to be honest with you. Let me just. Constant bool of that value. And then we're going to do a not on it. Let's just do that, shall we, for the time being. This should be fine. It shouldn't be a block. It's a TB node. This is a TB instruction region, like so. Nothing special about it. And then TB instruction set region name. So for that block, do that. Put -1 in there. And then we got a start block, which is not the same thing. So TB set control. That block. And then we have this monstrosity, which does exist, by the way, but by the looks of it, that's not the problem. It's not a module, it just takes the procedure in this case. And then we have an emit if, but the emit if is not what we want, but we can try it. Actually, let's try and do that. Void emit if CG procedure. What does it do? It takes in a value, the condition block and the true block. There's a lot of stuff in here. Interesting with this if statement, it does it with a... Oh, we add edges to stuff. So we do actually have to do this. This is why we do an if, because we're checking, like when we add edges, this is like adding edges to the... We're checking to see what the last parameter is, and we're adding stuff in this. Oh, I might not worry about that yet, is what I'm going to say. So I'm going to not do that yet. So just do admit if here. I think the blocks don't need to worry about the edges because they are already being handled by the system already. True bolts, false block, done. Func. Insert go to, that's meant to be a func. Probably another one I haven't done right. Func. Node dot node. Didn't need the incoming regions, did I? Apparently. Apparently. Where are the incoming blocks being used? At the end? Oops. Oh! Oh! Webcam's froze? Oh, bugger. How was the webcam froze? Because the camera still works. No, no. Can I just turn it off? And then back on again? Can I restart? Deactivate. Activate. Yeah, I don't think this works anymore. Yeah, oh well, there's no camera anymore. You get to see me without a camera, unfortunately. So sorry, guys. I don't think it's going to work without me restarting. Oh well, technology. Great, isn't it? So we can see me talking. I'm going to be here for another few more minutes, and then I'll be gone. Like, literally like 2 more minutes, maybe. Maybe. Just want to get this working. To do emit comp. What was this for? Oh, I never actually did this? Did I not? Oh, I did, because I just never wrote it. Oh, problem solved. That was easy. I've got a bug somewhere. Me trying to figure out an if statement. This is written in C++. Well, Tilde is written in C. The Odin part is written in C++, and then we're generating the Odin language, which is Odin. Hopefully that clarifies things. Again, does my camera work? Nope, still doesn't work. I'm just still trying to figure out how to get this camera to work without restarting things. Yeah. Hmm. To retry. So let's see what I've done wrong. I think I've got the wrong incoming block for each thing. So if we have a node, we need to know what the incoming region is of that node is, because it could be anything in that point. Which I think that's what the problem is. So it's not the values I need, it's the incoming regions thing. Like these are the incoming blocks, they're the incoming values. I might not need it, that's the thing, maybe I'm looking at it. So they got the region, the current, is that the current region or, and then A and B. Because let's step through the debugger on this, retry. And I clearly know it's going to be something wrong, like not equals. So Boolean to integer, not equals is what I did here. So what is the type of this value.node is my question. Type is 74, which is what? 001. This is a Boolean. It's a 1-bit Boolean kind of crap. But what is ST? Sorry, ST. That's an 8-bit Boolean. So they're not the same. So that's where, okay, I know what I'm doing wrong now. That was an easy thing. So make conversion. The ST thing here from the source type is what we need to be careful of. So if the source, so if value dot kind equals, I don't know, a value, then and TB is void, then we can change that to that. Yeah? Because that is the source type at the end of the day. No, value.node, sorry. What do you mean DT? It should have it in there. Unless it's huh? Yeah, there's DT in there. Or is it because it's a pointer? Thank you for the error messages. Now it's saying it's a null pointer somewhere. An address store. Which is probably actually okay. It says if it's empty, but it's got a... Wait, what? Because the address... Let's say value in here. There's the type is nil, but the value is nil. So it's not storing anything in there. That's the problem. So build statement is trying to store a value from... Oh, I know I've done wrong. Is it just the ternary expression thing? And I was about to go, oh, blooming heck, we've been raided! Raided! Oh, this is fun. Hello! This is fun. I guess this is good fun. Thank you, the Primogen, for raiding the stream. This is going to be really wonderful. I just noticed, like, the stuff when as well as my camera doesn't work, so you can't even see me. That's the problem. Like, black screen. No camera. So welcome to the chat, everybody. Welcome, welcome. How are you all guys doing? It's all been raided. This is wonderful. This is C++ I'm writing in. Shall I just do a very big thing to explain what's going on? Because that might help. I don't know. Yep. Don't mind it. I don't mind if this is fine. I don't mind the raid. Raid's good. So I think I've got to stay longer now by the looks of it, if this is a raid. But yeah, fun. Right. So we're just working on the Odin compiler here, and we're just doing a new backend system. So to go from the top here, we are using the quick backend system here. This is the quick C compiler, and it uses a specific backend called Tilde. So Tilde is an SSA based thing. This is called a static single assignment. I always get those words mixed up. Basic backend. We're trying to, the short answer is, if you don't know what you're talking about, we're trying to replace LLVM. We're trying to make an alternative to LLVM and be as good as LLVM can be. Which is doable, actually. Absolutely doable. So yeah, we're just here for the voice apparently. This is absolutely fine. As long as you don't have to see my face. You can hear my voice, it's fine. But yeah, so that's what we're doing on. So we're trying to be better than LLVM without doing LLVM. Now, LLVM, for people who don't know, LLVM is the compiler backend that you use for Clang. The C, like Clang is like C and C++ compiler. And that's what that is for. Now, when things are... How do I go this? Back in the day, so there's different C and C++ compilers back then. Can I just still get the camera working? Because I would use my face otherwise. Because like, why does none of this work? Like, it's stupid. You know what? I think there is a way of getting the camera to work without having to use this. This is going to be my ghetto stream. Come on. Right. Let's see if this works. It says it's not responding. This is a good sign. Oh. Yeah. I don't think this is crashed. Oh, wonderful that is. Absolutely wonderful. That just crashes. Welcome to technology. This is why you need stuff. So let's try a web browser. So webcam viewer. Let's just find something that we can do it on our... Can I do one on a web browser? I don't know how to do any of this. Right. The wrong webcam. Oh, but it's still trying to do this one with the Elgato. It crashed. It's crashing. Yeah, I don't think any of this works. Great, we just don't have a camera of me. You don't get to see my face. You just get to hear my voice. This is going to be the most intriguing thing in the world. Or maybe if someone... You know what? I know what I'm going to do. If I go onto YouTube, like this, rather than doing all the programming, we can look for my YouTube channel, find a picture of me, just as I'm about to... No, that was a bad image. There you go. That's me. How's that sound? There you go. That's me. That's a picture of me. So this is just a picture of me. That's how you do it. So can I do that? Oh, can I just add this as another scene? This is perfect. This is add a browser. Okay. No, that's not what I want. I wanted a window. Yes, I do want to move this. This is my ghetto image, guys. This is skill. You get to see a picture of me in the bottom corner still. So I'm gonna learn how to do this quickly. Source capture, window capture. That's what I wanted. That is the window. We're gonna do that. Put that there. Oops, it's now replaying me. This is not good. I just want to see. That's not... Let's just get a better... Let's go back to the original. There we go, that's me. So we are seeing a picture of me from the previous stream on this stream, which is not me. I'm really good with these ghetto simulations, man. These are really good, like, that's perfect. So now just imagine I'm talking. That doesn't work because now you're seeing the Twitch chat. I did not think that through. So, does that work? Yeah, that's even better. Look, you get to see how ghetto this is. Absolutely wonderful, isn't it? Right, so we got the comedy going on here tonight. So now let's just keep on with the thing. So imagine I'm speaking. Just imagine it, okay? You can imagine. Right. So what we're doing here is working on the backend stuff, and we've been working on actually making the compiler backend for the Odin programming language, which is a different one. Instead of using LLVM, where LLVM is kind of like the industry standard other than GCC, LLVM is used by LLVM is used by Clang, it's used by Rust, it's used by Odin, it's used by Zig, it's used by named a compiled language. It probably uses it other than it's say GCC. And as a result of this, it is kind of a bit weird and bad and buggy, and it's old, and we need an alternative. Like, the problem is with Odin at the moment, when we have compile times, it takes up 90% of the compile time minimum is LLVM. That's how slow it is, and how fast Odin is as well at the same time. So it's kind of well, what can we do about all this? And I would never wish anyone to use LLVM whatsoever. I would recommend them just do something else. So what we're doing is using the Tilde backend system. This is developed by a friend of mine, Negate, is his code name. And Tilde is a lovely backend system here. And again, we're just trying to replace LLVM. So that's kind of the idea. So I'm integrating it into Odin. He's incremented it into his own C compiler, and then we're doing that. GCC is not an option for us. The reason why we didn't want GCC is because the short answer of it is, can I do a loop? Now, this is even better. Can we loop on a certain section so we get to see me and it looks like I'm talking, but it's not? But I don't know. Yeah, so GCC is not an option because of licensing. Also, GCC is old. Like, it's as buggy, it's probably buggy as LLVM, and it's got things in it which are so much C-like and such, and it's just going to be, oh God, just an absolute pain. But for people who don't even know what I'm talking about, so what is Odin? You may not know. You may not have seen the Primogen interview with me. So the Odin programming language is what I'm developing. I am the creator and the main architect on the Odin programming language, and that's fine. So this is what I've been doing and what I'm developing for the compiler backend at the moment. So if you want to see this, just might shake this around. This is how it works, right? You get to see me shaking this, and this is me talking. So when I'm talking, I'm just poking this up and down, obviously. Now, with this language, again, it's as the thing suggests, it is the data-oriented language for sane software development. And we are trying to be a general-purpose programming language with distinct typing built for high-performance modern systems and data-oriented programming. We're trying to be an alternative to C on modern systems for like game development and 3D graphics and anything tooling in general, like loads of things in those systems. Now, when I created Odin back in the day, there wasn't any alternatives, so I needed to just make one. And if I recommend watching the Primogen stream on this topic, here it is. Oh, no. I'm very smart, me. Like I can do this, right? There's one in Odin somewhere. Somewhere. Is it not on this one? No, it's one of his channels. Is it the prime time? Oh, just, you know what? Odin. Programming? Not, because Odin's a guy's name as well. So this one. This is the video I'm talking about. We can see it into the chat. And if you want another link elsewhere, this is me. Obviously, now you can see another version of me as I'm talking, but it's not really talking. But that's it. Yeah, so this was on the prime time. Yeah, he has too many channels. I know why he does. I am a guy, so this is me in the top right. I'm not the bottom right. I have a beard, not a mustache. You can't see me anymore, but there you go. So I can cover up with yesterday's photo rather than today's photo. You know what I'm doing, right? This is me talking. This is how I'm speaking, whatever I'm doing. So this is a very good video for what you need to do. Yeah. So I'm the developer of the Odin programming language, and this is what I'm doing. Hopefully the up and down thing makes it sound like I'm talking. Is it right? Yeah, the camera doesn't work. And I can't make it work without restarting OBS. And I don't want to restart OBS because I'm streaming. Welcome to technology, guys. It's brilliant. This is, if you're convinced by me talking, this is wonderful. You know what? We can probably make this slightly better. Right. This is how ghetto I am at times. No, let's make it 200. 300? Ah, there we go. 300 as well. about 100, I'd say. No, 190. Yeah. And the bottom, let's go another 190. Yeah. There we go. Look, now we've got it. Oops. Now we got it. And now this is me in the bottom, but it's just an image. It's perfect, right? Perfect. You never knew. We could do it, but I'm like, I don't care. I'm just going to do it. So yeah. What's the problem to solve? Why use Odin instead of C++? Well, let's put it this way. If you've ever programmed in C++, you would know the answer to that. Unironically. Like, why would you want to program in C++ if you have an alternative? Who'd have known? Yeah. So this is what we're doing today. And we're working on a new backend for it instead of LLVM, and that's how it kind of works. So yeah. Hope things are going all right, guys. Is this Rust 2.0? I hope not. No. So if you want to try Odin, just go to the Odin website, just go to odinlang.org. And if you want to have any basic questions, make sure you go to the community as well. Like, we've got the lovely Discord server and such if you want to ask for help. But yeah, you can also try it now. Odin is a lovely language, and it's, yeah, there you go. So why am I programming C++ now? That's a very good question. So the Odin compiler is written in C++. It's not written in Odin because I don't want to do that silly thing. So why, again, are you building a compiler? Sounds like LLVM has a university of people doing it. Yeah, that doesn't mean it's good. I've been using LLVM full-time now for about, 7 years? And it's awful. And there's no other alternatives out there, very much. So just need to do that. And just because it has a lot of people working on it, again, doesn't mean it's good. And just because, again, it's old, it's 20 years old, so it's very, again, it started as a university project, and it's got a lot of cruft to it, and you can't really do anything about that. But we need to improve the compile times as well, like, and also get rid of the books and make, you know, the different benefits we can get. Why isn't Odin more popular? Well, you just need to tell people, don't you? You just need to tell people to be, so they know about it. That's pretty much about it. Because once people know about it and try it out, they usually love it. That's kind of thing. And if not, it's not great, it's fine. At least you've now got options out there for when you're looking for things. Isn't that great? Yeah? Good. Yeah, wonderful. It was funny, as soon as I was about to leave, the Primogen just came on and raided. Thanks, the Primogen. Yeah, there's a story. If you want to learn any real general information about Odin, you can. We've got a lovely FAQ here, how it started. It's got a bit more sense thing. If you can, I also, in the chat I did with the Primogen, I explained some stuff in the beginning and also in the end of how it started. So that's kind of what is doing on here. So I recommend that video as well. So there's always wonderful things we're doing here. So carry on. There's a lovely FAQs about all of the different stuff about Odin, if you want to know that, why I created it, why this language, why not another language, and etc. etc. Is null part of language? Nil is yes, and that is pretty much, you have to kind of have it. So it's not something like, because it's a C alternative and you're dealing with C like stuff in general, you will have it regardless. Like, it's not something you can get around. And at the end of the day, and also practically, I'm probably in a very weird camp where I think a nil pointer is just another invalid memory address, and it's just like a category of invalid memory. In fact, it's the easiest ones to catch usually as well, because for people who know how machines work, like modern machines, they have virtual memory, and the first few pages usually are protected. So if you try to read or write from that first few pages, including like where the nil pointer is, it will crash, and it's empirically easy to catch. It's the ones which are the other invalid memory addresses, which are still valid to use. They're the nasty ones, which, again, you're not going to be able to get easily done. Odin has pointers. Yes, yeah, already. It's been had since day one. Yeah. So no bad preprocessor. Yeah, so the reason why is, when we say preprocessor, we don't even have a preprocessor on Odin. That is what it is. So you know what? I can probably get a stream chat thing popping out somehow, so I can see it on the chat. I don't know. I don't do Twitch. This is the second day I've been doing it all week, and I clearly am not one of those Twitch people who knows exactly how to do it. Like, is that a chat, people? And you can see. So there we go. This is the stream chat. This is how you wonderful do things like this, isn't it? Can I do that again? I can do another window capture and put it there. We're going to just be like a billboard at this point. Window capture for this, and the one I want is I have no idea which one it is. Is it that one? No. Is it that one? No. It's one of these? No, it's not that one. I don't know what I'm doing. You think I know what I'm doing when it comes to Twitch? If you thought that, you were misinformed, and that doesn't stay there, does it? Right. That kind of... There we go. Can we zoom in a little bit more for that? Wonderful. There we go. You now get to see the chat while I talk, and this is beautiful. You have to admit, this is beautiful how you program. Anyone who disagrees with me, I'm sorry, just wrong. Okay? Right. This is pro. This is so pro. We have an image of me that I'm just dancing up and down to make it look like I'm speaking, and that's how it works. So, back to this. So we're looking at doing this. We for the Odin program language, we make many beautiful things in it and such. And one thing to show that we use Odin, like why would we use something else? It's like, well, should we show it? We can show Embergen off, but it'd probably just crash the screen anyway. But whatever. Yeah, I'm glad that people think that this is believable for me talking. I'm so glad about it. Thank you. Thank you so much. Again, I'm so upset that the video died just before you guys came on. Yeah. Whatever. This is how you do it. So when we're talking about making a new compiler backend anyway, the whole point is we want to be faster than LLVM. LLVM is so slow. And yeah, this is just, it's really annoying. Because when you're compiling stuff, like for instance, I work on Embergen. So again, just to, not trying to plug things, just literally just trying to show you what I do. And go to, this is Django Effects, the company I mainly work for. And we develop a software called Embergen. You probably have seen Embergen around. It's for the real-time volumetric flow and simulations and stuff like that. It's a bit of a mouthful. I've just spade there, but it's really cool. It's fire and smoke and explosions. You probably, if you played a game, you've probably seen our software. Is what I'm saying. It's pretty good. Look, we're in good company. And again, all of our products at Django Effects. This is Embergen, Liquidgen, Geogen, all use Odin. So that's why we program, because we'd rather use Odin than C++, because C++ is an absolute nightmare in comparison, but it was the only alternatives at the day. And I know many of you people also like Rust in there, and unfortunately we're not rewriting anything in Rust. We clearly did it all in Odin. So yeah, that's why. But again, if you want to do it in Rust, we'll do whatever. Great, as long as we have alternatives. So I'm just being the ventriloquist today, and thank you. Thank you very much. What terminal emulator am I using? CMD. Yeah, here you go, CMD. It's beautiful, isn't it? The best terminal emulator known to man. This is beautiful. Yeah, Odin's technically in production. Do I recommend people use production? There's no warranty, so that's your answer. But yes. Embergen, Primogen, is that a coincidence? Yes. Right. But that's absolutely fine. Actually, you guys missed, I was talking about Rust earlier, actually, about speaking about like lifetime semantics and how they're not even good enough, in my opinion. Like, it's not even criticizing, they're just like, they're not good enough. But I'm not going into that discussion before. You'll have to watch the VOD on this later, obviously, because you missed out so much banter. But yeah, this is, I'm sorry, do you not like my amazing stream? In fact, I could probably make this a little bit. Yeah, I'm not doing an Odin Foundation, don't worry. And also, Odin's a person's name. It's very hard to trademark that. And also, why would I trademark that stuff? But yeah. So you work for the company, and the company is fine with you having full ownership over the language they use. Yes. Someone has to own a language. Own the language usually. So, yes. I'm not changing it. The language is done, effectively. It's been done for ages. I'm just working on like the compiler stuff at the moment. So that's absolutely fine. Oh, what time is it? We got fine time. I was going to get going, but this is the problem is, let's say 20 minutes. Shall we do 20 minutes so we can try and fix this bug that I've had? Because it's just, we have to go through the compiler in a minute. Okay, debugger. Empty value. Why was that empty value? Oh yeah, because I had a hunch. It was in the ternary if expression thing here. I don't think, I returned a, yeah, I never actually set the type. That was the problem. Type. So we do that. Now it works. Woohoo! You know, it happens. Most of my bugs are typos. Sorry. most of my bugs are typos. I nearly forgot the ventriloquism here. So looking through the chat, I'm missing loads of here. Okay, Gingerbill, if you need to go, just go. I'm fine. I'll be here for another 20 minutes, and then after that, I really do need to go. I've got things to do in my life. I have a life. Who'd have guessed? But yes, trying to trademark Odin, yeah. So, I don't know, people trying to trademark Rust. Who'd try this? Yeah. If it's used in production, when a bug ensues, how often should I think that this is a runtime bug or a program bug? It depends what the bug is. If it's a compiler bug, it usually has a big assertion, so there's a compiler error. That's usually what happens. But most of the time, it's pretty stable, at least for AMD 64 and ARM 64, those platforms at least. Ironically, you should look to, I even not doing any of these plugins to do the voice. Maybe there is a plugin to do this, to the ventriloquism. I don't know. I don't want to spend the next 20 minutes figuring that out, but I'm just going to start to do some programming. So I'm happy we've got ternary expressions working and just looking through the code. So I'm just going to copy and paste this IR, and hopefully we're going to teach you how to read IR today. So IR means intermediate representation. And bug. This is the code that we've generated. Ignore that comment. This is the code. We're making a new backend. It's not that fancy, but effectively we have a procedure named main, and it has a variable named x, y, and z, and we have an if statement here. Like, look, an if expression here. Like, we do x plus y if x is greater than 0, else do x minus y. Oh, great. So now we can look through this code and see how it correlates. This is just an IR that I got Negate, who is the creator of Tilde, to put this out to me the other day, and it's absolutely wonderful. So the IR here is just an easy way of understanding what's going on and how to read it. So one of the problems we have here is like, okay, this is a context variable. You can ignore this code entirely, but that's fine. So this thing here is the x variable. It's named x here. So this is a local. It's going to be a pointer because it's a pointer in memory. It's of 8 bytes and it's size of 8 and 8 alignment. And we're going to just zero the memory off here. But then once we've ignore this 0, there's no optimizations on here. We store the number 2 to it. That's it. So store 2 into v2, which is what x is, the pointer to x. Yep. We do the next thing for y, and we do the exact same thing. But in this case, we need to do add 1 plus x. That's what it does is. And you can see here, you got add an i64, so an integer, 1 v4. Great. Done. This needs to be gone, and I need to get rid of that, but that's a different thing entirely. Then we have a load instruction. So this is a load to get the value, because we had to load v2. Yeah, because we loaded this value v2 here. We're loading it again. So it's the same load, but there's a fence in between, so it means it might be a different storage somehow, but we'll optimize out if we do mem to reg. The next thing here is we have to do a condition expression. So we go into this block here. We get projections, make some new control blocks, do control, whatever. This is doing a comparison. So we're doing is x less than equal to 0. And then we can comparing this against 0. And then we're going to do a sign extension. And then this is just a bit junk here, but ignore that. Then we're going to just convert this to a v1. So what this is doing is converting this to say, hey, if it's the true case, we need to go to the if then block. And if false, we go to the if else block. Oh, isn't that wonderful? That's all that's saying. So if it's true, we need to, which is true in this case, by the way, we go to the if then block. This is the intermediate representation for Tilde. It's nothing fancy. We can then load the value from v2, remember was x, and we'll load the value from v5, which was y. And then what we need to do is we go and jump to the done condition, and we do the subs here for some reason rather than there. So we do a sub here, and then we do the phi. Interestingly, it does it there. I might have done some code generation bug here, but maybe not. I don't know. I'm finding out. Why is it done the sub here in this done? But yeah. God, that link's old. Insobot's old as well. So the better link for Odin is probably the actual website. Like that. Yeah, what's phi? So this is, oh God, we're explaining phi nodes to people who don't know. And this is, I can draw a phi node. You know what? Let's just get my graphics tablet out. Yeah, I've got the graphics tablet. Let's get Milton open. Yeah, okay. So I'm going to teach you the basics, the very basics of static single assignment. Like so. right? This is static string assignment, also known as SSA. Really, really simple. Great to know. Now, who here knows what a switch statement is? Yeah, most people know what a switch statement is. So when you have a switch statement, this is like ass, but backwards. I know. It's like a backwards ass, so maybe it looks like this. So it's more like boobs. I don't know. But if you have a switch statement, right? So a switch, right, like this. We can have some value in the switch statement. Let's just call this X, right? And then we can go to the different cases of this. All right, so we have case 1, case 2, case 3. I'm just writing this randomly as we do this. So another way of drawing this would be in a graph representation, yes? So the graph representation is we have a switch, and depending on which value is, if it's 1, 2, or 3, we go to these different blocks. So we could go to block 1, block 2, or block 3. This is what a switch statement is, okay? We're going from 1, depending on what the value is, if x equals to 1, x equals to 2, or x equals to 3, it takes you to the different blocks. Great. Now we're going to learn what a phi node is. So a phi node is fundamentally something that's only in SSA. And this is not a high-level construct. This is something for optimization benefits, yeah? So what happens is a phi node is slightly different. I would call it the exact opposite. So let's say you have block 1, block 2, and block 3, and we all come to this other block, right? So, right, we come to this other block, and at the top it has this phi node. And in the phi node it says, if we came from block 1, the result is going to be, let's say we have a value of 1. We came at block 2, we had a value of 2. And we came from block 3, we've got a value of 3. So depending on which block we came from determines the value of this node. Does that make sense? So it's very much the opposite. Like this is switching on the value and going to a block. And this is effectively like, hey, depending on which block we came to determines the value. Yeah? So it's kind of like an inverse switch. This is what a phi node is. This is what sometimes you want to see Greek letter phi like that. You'll see the phi node. And this is what in these weird like academic papers. I was an academic at one point. I hate academia, unfortunately. It wasn't for me. But like, yeah. And by the way, I was an academic physicist, not a computer scientist. Like I get by with computer science. So this is kind of what the phi node thing is for. So phi nodes are really useful for like generating the graphs, because when you're doing SSA, like notice what I've just wrote here is a graph. I've got like a node that goes to another node like this. Yeah, these like nodes and edges. And then we come back to another node like this. Yeah, so it's just representing this as like nodes and edges. So these are your nodes and these are your like edges or your connections or whatever. And that's how they all relate to each other. And that's kind of the nice thing to do it. What uses a block? So I make a block. So we don't, in the technical literature, they don't call basic blocks. LLVM calls them basic blocks. Tilde and the actual literature calls them control regions. So this is a region of control. So a good example of this is, let's say you'll think of an if statement. Let's do the most simplest example. So condition. So do this. And then we're going to just call, like, pretend that's not even a squiggly brace. That was number 3. Yeah? We have A in here, and then we have B outside, right? This is structured control flow. Well, before structured control flow existed, we have something called assembly. And what you have in assembly is you do, like, for instance, a compare. Let's do a comparison of the condition against 0. So it's a 0. So that's a 0, by the way. Yeah, that's a 0. And we have the block of the body. So we call this the body. Yeah. And then in this, we do the thing. So I'm actually, no, let's just do flatten this. Let's make it more SSA-like for us, shall we? Let's make it do this. So we have let's say an if statement. So this would be like a branch. So if a branch, we have the condition, and in the true case, we go to the body. This is if in the true case, so true. In the false case, we go to the done body. Yeah, so then we can call A, and then we done. So we need to do a done scope here, block, and then we can do call B and then ... to carry on. And then what we need to do here is a jump to done. Yeah? So this branch here is saying, hey, if it's true, this condition is true, jump to the body. If the condition is false, jump past to done. Yeah? So this is, you can see where go-to came from exactly. This is exactly what go-to anything is. You're just representing this as this. Now, clearly structure control flow is much better. But when you're actually writing a compiler, you want this style actually, because you want to be able to have the control. We're not working at the high level anymore. We're at really, really low level. And that's kind of what's going on here. Hopefully that makes sense. So there is no else. Now, what about if we wanted to add an else condition to this? Yeah? Let's add an else condition. And it was just, so I'm going to rewrite all this, by the way. So I'm going to write an else condition for us. So let's say we've got another call in there, and then we've got the end out here, right? So the else condition, you could easily implement like this. So we could just say, here's an else block. Yeah, we have the else. And then we can call B, and then we jump to done. And then we start the done block. And then dot, dot, dot. This, if you can see it past my static head, and you saw the I didn't see the chat, like so, as they say in Blue Peter. That is how you would implement an if statement like this. This is kind of like pseudo assembly or pseudo like IR, whatever. So this is like pretty much like assembly. Yeah, this is kind of what it is, but this is more, it's more abstract with like an SSA based IR. And that's what you're trying to do. But the thing is, this is like a linearized form of it. The way it's actually represented, I was trying to explain, it's actually represented as a graph. You've got these nodes and edges that you're trying to represent and what is going on. Make sense? Good. Hopefully people are learning something today as well. You're getting a fun lecture on SSA because I'm like, I wasn't going to program anymore, but I'm like just going to talk to people about this. Great. Is it your responsibility to implement the structure control flow for Odin? Yes. Or is it something you need to reach when you need control? No, I implement all the control flow, obviously. This is kind of the thing like in the compiler, like the backend. This is what I've been writing on these streams. So I'll be doing this all week, hopefully. Don't know what times I'm doing it at, but round about now-ish kind of thingy, my bob. That's what I'm doing. So the one statement that made SSA click for me is that branch equals conditional go to. Yes. A branch is just a branch. It means that you jump to something. A conditional, yeah, that's one thing. For me, from SSA, the thing that made me click was realizing it was just graph theory. It was literally this. That was the thing that made it click for me, and yay. Yeah, it was. So fun. All fun. So, any more questions? Because I actually don't mind answering questions, because I'm only going to be here for another 8 minutes. Can you give an example of when the graph representation is useful? Yes, knowing dependencies. Like what depends on what. Because if you have a variable, like literally have something here, actually these things depend on that, depend on that, depends on that, and depends on that. The graph representation shows you how the dependency works, and you can go up the graph tree. So I'm going to see if I'm actually going to show it with the Tilde backend system. So this little code I've written here, hopefully works. Compiled, I think. But I want to go to Tilde proc, and I've got the printing function here. This is just the, I want to do the function print is what I want. Yeah. And I want to do the other printing of the function. So this is that. I need to put the default printer and then standard out. So let's build this again and see what this does. So this is the, God, it just printed it in between, didn't it? Because of course it did. This is a graph visualization of that same IR that we've just seen, by the way. So what I'm going to do to this is look for the graph viz online thing and add in that. And now you get to see the graph representation. Oh, is it a syntax error? Where's the syntax error? Why cocked up? Let's just get rid of this print and just print the other one. And hopefully, oh God, it just did this again, didn't it? So, like that. And then do that. This is just clearly just debug stuff I'm trying to do at the moment. Right, it's rendering. Oh, where's the syntax error? Line 1 near dot. Oh, it doesn't like the dots, okay? Let's call it that. Let's call this main, okay? Right, this is the graph representation of the code we just looked at. The same IR, this is the graph representation of it. And the red lines, in this particular case, I can't see if you can, you know what? Let's save this image somehow. Or make it a bit, can I go across? No. Well done, technology. I like technology. It's great. Right, it's not like it's got, yeah. Right, so this is the graph representation of the same code. Now, that is some clean code, I know. Mr. Martin would approve. I know that's a bad joke. No, he wouldn't. He really wouldn't. Let's just carry on with this. This is the graph of it. So we can zoom in to make it a bit easier to show people what it is. So this is starting off. This is doing some of the variable initialization and storing them, or doing memset on a lot of them as well. Yeah? But notice this red line. This red line is the flow, control flow, like what's actually happening with the program, while the black lines are showing the dependencies. These are the dependencies on this system. So it's like, yeah, we're actually showing what is going on here. Yeah? So you will be able to see some phi nodes on here as well. Like, we have a phi node somewhere. Here, here's the phi node. Look, do you see the phi node? It came in. Look, if it came from branch 0 or came from 1, it's going to be different values depending on what those things are. And then it's going into a store and then returns. This is literally what is going on in this phi node. You can see everything going into the phi node and one thing coming out. Does that make sense? So this is kind of a way of representing things anyway. Now, I wouldn't recommend anybody use Tilde yet. This is the thing. I am literally helping develop this. This is still so early. It's just we want to make an LLVM replacement. So we want to know that we've got all these decent tools and showing what's going on here. So hopefully this is kind of exciting to people and also like, wow, you're learning some stuff about compiler development and all the fun things that come with it. Yeah. So it's wonderful, isn't it? Isn't it, right? Yeah. But like, this is showing you the program. Like, we could actually start from the thing. We do some storing into this, like store 0 into this, it's fine. You've got mem 0. Do another store, does another mem 0, does another store. Then it does a branch. Like if it's true, this is the true condition, this is the false condition. So if it's true, we go into this thing. We're doing some, another region and doing a store. We're doing a subtract and it's all that into a phi. If we go into the other false condition, we were doing another, we did an add in this case. Remember, we did an add x and y. The other one did x minus y, whatever. And then it goes, if it came from this condition, we do this. If it came from this condition, do this. There's your phi node. And then it goes into here. So it's very much this is the control flow. It's hiding the phi node magic for you, but the phi node is there. Magic, isn't it? This is British. Int it, right? Int it. It seems flipped. Phi nodes are flipped. That's the point. They're an opposite to a switch statement. But this is kind of the lovely thing that's kind of going on. Like, whee, there we go. I don't remember which one was doing the subtracting. I might have implemented because I've only just written it. Yeah, the false is doing the... Oh, I don't know. I haven't figured this out yet, okay? I'm still like doing things. It's like still developing. You saw me like write the code on stream today if you were there earlier. If you're not, I'm sorry, I apologize for that. For the rest of like 300 of you, believe me, it's more nearly 300. There was like 1,500 when it got here, but now it's 400 of you, and wow, okay, that's a lot of people. Ooh, yeah. Right, so I think we're going to start winding down, but yeah, this is all the cool stuff. Again, you represent the graph thing here. It's one thing. You can represent it as the IR that we saw, or again, you see the more high-level Odin stuff, and you can see how much complex your actual code is, like what actually is there and what it's doing. Yes, the graph is shown for optimizations and such. There's loads of things, right? Why you want to use a graph rather than not. But yeah, I'm just so God. I'm really annoyed that this camera died for some reason, but it made some comedic things again for my lovely, how do I call it, ventriloquism with the speaking here. This is great, right? Speaking ventriloquism. But yeah, so thank you all for watching. This has been really fun. I will be doing this again tomorrow. The time I'd be doing it at would be about, I don't know, I don't know. It's the afternoon in like British time, okay? Whatever that is, like the same time I did like today-ish kind of thing. So probably from like 3 p.m. onwards till about 5 or 6 p.m. at the max. So hopefully this has been interesting to you. And thank you all for watching. Now the question is, who should we raid after this? If we raid anyone at all. Is there anyone like streaming that I know? Is there anyone streaming that I know is the question. Yes, but no. Damn it. Oh, well, it's fine. Well, thank you very much for all coming, and I guess that's a good night to everybody. Have a nice evening, everyone, and goodbye. Whee!